Okay, everyone. Our topic today is Taylor and Maclaurin series. So, what do you understand by Taylor and Maclaurin series? Taylor and Maclaurin series are basically the same thing, just that Maclaurin series is when your A or your X equals to 0. You can get Maclaurin series from Taylor series. Take a look at this formula written on the screen. Assuming your A equals to 0. From Taylor series, assuming your A equals to 0, it means that f of 0 plus f prime of 0, open your bracket, minus, open your bracket, x minus 0. What are we trying to do? We are trying to prove that your Maclaurin series and your Taylor series, they are the same thing. But your Maclaurin series is when your A equals to 0. So if you know your Taylor series, automatically you know your Maclaurin series. So let's assume A equals to 0 here. Then using Taylor series, using this formula here, you know f of 0 plus f prime of 0, open your bracket, x minus 0, then we have plus f double prime, your A is your 0, over 2 factorial, x minus 0, don't forget your square, then we have plus f triple prime of 0 over 3 factorial, x minus 0 all raised to power 3. Then let's simplify this. This will give f prime of 0. This will give f prime of 0 plus f prime. We are trying to simplify this. Then f prime of 0, open your bracket, x minus 0. That will give you f prime of 0, x minus 0, that's x. Then this will give plus f double prime of 0 over 2 factorial, then x minus 0 square, that will give me x square, plus f triple f triple prime of 0, 3 factorial, x minus 0, that's x raised to power 3. When we take a look at this, we will know that this thing, this formula we wrote here is the same as our Maclaurin series. So if you know your Maclaurin series, can you see it's the same? If you know your Maclaurin series, if you know your Taylor series, rather, you can easily get your Maclaurin series. Let's solve these examples here. Let's solve this example. Now, we have find the Taylor series of f of x equals to cos x about x equals to 0. So we were asked to look for the Taylor series of cos x. We're given f of x equals to cos x. Now, what will be the f prime of x? F prime of x means when we differentiate cos x, what are we going to get? We will get negative sine x. F double prime of x, when we differentiate this again, we will get negative cos x. When we differentiate this the third time, we will get plus sine x. Let's stop at the fourth derivative. When we differentiate this the fourth time, we will get cos x. Now, do not forget, we are looking for the Taylor series. Now, f, and we're giving x to be 0. So f of 0, when you press your calculator, cos 0 is what? We know cos 0 is 1. F prime of 0, f prime of 0, what will that give me? Solve that. f prime of 0, we know our f prime equals to sine x. So what will my f prime of 0 give me? My f prime of 0 will give me 0, because sine 0 is 0. Then f double prime of 0, this will give me negative 1. F triple prime of 0, this will give me 0. The fourth derivative of 0, this will give me 1. Now, let's input this into the formula. Let's input this into the formula. We know the formula, this is the formula. Now, let's find for f of, so this will give me f of 0 plus f prime of 0 x, do not forget your x, plus f double prime of 0 x square over 2 factorial plus f triple prime of 0 x over 3 factorial. If I may ask, what is my f of 0? F of 0 here, we can see is that f of 0 from this formula, f of 0 here is 1. Sorry, f of 0 here is 1 plus f prime of 0. F prime of 0 here is 0 plus f double prime, that's negative 1 x square over 2 factorial plus f triple prime, that will give me 0 plus the fourth derivative, that will give me 1, sorry, that will give me 1 multiplied by x raised to power 4 over 4. So now, let's solve this. So this will give me 1 plus, this will give me negative x square, 2 factorial, that is 2 times 1, plus x raised to power 4 over 4 factorial is 4 times 3 times 2 times 1. So this will give me 1 minus x square over 2 plus x raised to power 4 over 4 times 3, that's 12. 12 times 2, that's 24. Remember to put your dot, your infinity sign. So this is the Taylor series of cos x. This is the Taylor series of cos x. So this is tending to infinity. If we were asked to look for the fourth term or the third term, then if we are asked to look for the third term, then we can stop here. But because we were asked for the Taylor series of cos x, then this is tending towards infinity. Now let's take a look at the second example. The second example says, determine the power series of cos 2 theta. Cos 2 theta. We were asked to determine the power series of cos 2 theta. Using the power series of cos x, we know cos x equals to 1 minus x squared over 2 plus x raised to power 4 over 4 factorial. Now, since we know cos x, our cos 2x, we give 1 minus, our x here is 2 theta. So this will give me, sorry, so this will give me 2 theta. Wherever we see x, we will put 2 theta over 2 factorial plus 2 theta raised to power 4 over 4 factorial. So this will give cos 2 theta equals to 1. When we simplify this, 2 theta all square, that will give minus 4 theta square over 2. And this will give me plus 2 theta raised to power 4. That will give me 16 raised to 4 theta over. When we simplify this the other time, we got 24. We got 24. So let's continue simplifying this. This will give cos 2 theta equals to cos 2 theta equals to 1 minus, this will cancel this, 2 theta square plus, when we simplify this will give me, 2 can divide, that will give me 2 over 3 theta raised to power 4. So do not forget, this is tending towards infinity. So this is the solution to our second. They might also give you cos 2x. It is the same approach. It is the same step. So since you know the Taylor series or the Maclaurin series of cos x, sin x, and every other unique identity, you can find anything. Let's quickly solve the third example. The third example says, using Maclaurin series, find the first 5 terms for the expression of the function f of x equals to e exponential 3x. So let's solve the third one. We're given f of x equals to 3 exponential 3x. Exponential 3x, sorry. So solving this, what were we asked? The first 5 terms. The first 5 terms. The first 5 terms of this, it means we should differentiate 5 good terms. That will give me f prime of x equals to, when we differentiate this will give me this. It means this will multiply the coefficient of e. So when I differentiate the second time, this will multiply this. So this give me 9 exponential 3x. So when we find the third derivative, this will give, this will multiply, this will give me 27 exponential 3x. This 3x will remain constant. So this will give me, when we multiply this, that will give me 27 multiplied by 3, that's 81. A3x, the fifth derivative. So that will give me 81 multiplied by 3. That will give me 2. 243 e raised to 3x. So when f of when f of when f of x equals to exponential 3x, f of 0 will give me, so this is how to solve it. It means I will say, and this will give me 1. F prime of 0 will give me 3. F double prime of 0 will give me 9. F triple prime of 0 will give me 27. The fourth derivative of 0, that will give me 81. And the fifth will give me 243. So now let's use the formula. Let's input it into the formula. The formula says f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 x 3 factorial, like that. You observe something here. The degree of the of the of the f prime is the degree of the x. So it's very easy to memorize. So let's substitute. f of 0 is 1. So that will give me 1 plus f prime of 0, that's 3, plus 3x plus f double prime, that's 9. So that will give me 9x squared over 2 factorial plus f triple prime, that will give me 27 over 3 factorial x raised to power 3. For the fourth one, that will give me 81 x raised to power 4 factorial. Then we have the fifth, give me plus 243 raised to power 5 over 5 factorial. So we can just easily simplify this. This will give me 1 plus 3x plus 9 divided by 2 factorial. That will still give me the same thing. 9 over 2x squared plus 27 over 3 factorial. That will give me 9 over 2x raised to power 3 factorial plus x raised to power 3 plus 81 over 4 factorial. 81 over 4 factorial. That will give me 27 over 8 x raised to power 4 plus 243 243 over 5 factorial. So that will give me 81 over 40 x to the power 5. So this is our answer. Sorry. This is our answer. So it's quite basic. Just follow the steps, and like series deals with just differentiation basically. So I hope you understand. If there is any part of this video you did not understand, let me know in the comment section so that I can clarify that in my next video. Thank you, and see you in my next video.